Good afternoon, Guido. It's great to have you here.
Good afternoon, Jeff. Thank you for having me.
Let's start with a brief introduction. Can you tell me a bit about your background and experience?
Absolutely. I'm Guido van Rossum, and I created the Python programming language. My career has spanned several decades in software development, focusing on simplicity and readability in code. I've worked at companies like CWI, Google, and Dropbox, contributing to various projects and promoting the adoption of Python in diverse domains.
Impressive background. Python has had a huge impact on the programming community. Let's dive into some technical questions. How would you optimize a Python application for performance?
Performance optimization in Python can be approached in several ways. Firstly, profiling the application to identify bottlenecks is crucial. Tools like cProfile and line_profiler are useful for this. Once bottlenecks are identified, one can optimize critical sections of the code by rewriting them in C using Python or leveraging existing C extensions. Additionally, using efficient data structures, optimizing algorithms, and minimizing I/O operations can significantly improve performance. For concurrency, using asynchronous programming with Asyncio or leveraging multi-threading and multiprocessing can be beneficial.
Great insights. Can you explain how Python's global interpreter lock, GIL, affects multi-threaded programs?
The GIL ensures that only one thread executes Python bytecode at a time, which simplifies memory management but can be a bottleneck in CPU-bound multi-threaded programs. In such cases, the GIL can prevent true parallel execution of threads, limiting performance. However, for I/O-bound programs, where threads spend most of their time waiting for I/O operations, the GIL's impact is less significant. To bypass the GIL for CPU-bound tasks, one can use multiprocessing or write performance-critical sections in languages that don't have a GIL, such as C.
Interesting. Let's switch gears to system design. How would you design a scalable web service for handling millions of requests per day?
Designing a scalable web service involves several key components. Firstly, a load balancer to distribute incoming traffic across multiple servers is essential. The backend should be stateless to allow for easy scaling, with sessions stored in a distributed cache like Redis. Using a microservices architecture can help isolate different parts of the application, making it easier to scale specific components as needed. Databases should be designed for scalability, using sharding and replication. Additionally, implementing caching layers, both at the server and database levels, can significantly improve performance. Finally, monitoring and logging are crucial for identifying and addressing issues promptly.
That's a solid design. Now, let's talk about leadership. Can you describe a time when you had to lead a team through a challenging project?
One challenging project was transitioning Python 2 to Python 3. It required significant coordination with the Python community and a clear communication strategy. We faced resistance initially due to backward compatibility issues, but by outlining the long-term benefits and providing tools and resources for migration, we gradually gained support. It was important to listen to the community's concerns, address them, and ensure a smooth transition process.
That must have been a complex task. How did you handle the community's concerns during the transition?
Open communication was key. We held discussions on mailing lists, organized community events, and provided detailed documentation and tools to assist with the migration. By actively engaging with the community, we were able to build trust and demonstrate the benefits of the transition. Patience and transparency were crucial in addressing concerns and making the process as smooth as possible.
Excellent. To wrap up, how do you see the future of programming languages evolving in the next decade?
I believe programming languages will continue to evolve towards greater simplicity and readability, making them more accessible to a broader audience. There will be increased emphasis on concurrency and parallelism to leverage multi-core processors efficiently. Languages will also become more domain-specific, providing powerful abstractions for particular fields. Additionally, advancements in AI and machine learning will influence language design, with features to support these paradigms more natively. It's an exciting time to be a part of the programming community.
I completely agree. Thank you for your time and insights, Guido. It was a pleasure talking with you.
Thank you, Jeff. It was great discussing these topics with you.